Okay, today is day 2 of logs, and today we're actually going to be evaluating or solving or getting an answer for some of these problems. Last time we were just rewriting them so that we'd have the ability today to solve some. So the first group of problems says to write as an exponential function and then evaluate. Well, we do actually know how to do that because this 7, if you remember, is our base, so it's 7, and then these two things flip, so it's 7 squared equals x, and we can solve. I don't know, I was writing another 7. X equals 49. That's it. All right, let's look at the second one. 5 is our base, so we're going to have 5. These two things switch, so it's 5 to the third equals x. Well, if I'm trying to evaluate that, 5 times 5 is 25, and 25 times 5 would be 125. So x is just 125. All right, number 3. So 25 is the base. These two things flip, so 1/2 is the exponent equals x. Now you got to think back. What does something to the 1/2 power mean? Something to the 1/2 power means that x is going to equal the square root of 25, which we can evaluate. Because this is an even radical, we're going to get both plus or minus 5. All right. It was an even because there's an invisible 2 there that we don't write when it's just a square root. Okay, number 4. Log base 8 of x equals 1/3. So I have 8 to the 1/3 power equals x. Well, to solve that, I need to take the cube root of 8. Well, you can just remember it's 2. Or if you don't, you could make a factor tree. And because it's a cube root, we're looking for groups of 3. There's nothing left over, so my answer is just 3. Now remember, on this one, I am not going to write plus or minus because this is an odd root, so I don't need a plus or minus. Okay, back in chapter 6, we wrote this out one day in our notes. We wrote out the perfect squares, the perfect cubes, the fourth powers. Well, I'm going to tell you the same thing I did then. I'm not going to quiz you on this that you have to have it memorized, but man, it's going to make your life way easier if you know some of these numbers without having to think about it. Now, if we were not doing online school and I was teaching you in person, when you took a quiz, you're going to have to do some of the problems coming up without a calculator. And the only way you'd be able to do that is if you just knew these numbers without thinking about it. Obviously, I can't control that now that we're in online school, but know that it's possible on a standardized test that something like this could come up without a calculator. And how are you going to go about doing it? Well, you need to be comfortable with these numbers. So I don't know if you want to screenshot it, if you just want to make a list of these to have at home next to your desk to refer to, whatever you want to do. I'm flexible, but you need to know them at some point. All right, so the first one says write as an exponential function and evaluate. Well, we've been writing them as exponential functions before. That's no big deal, but they always equaled something, and these don't. So we're going to write equals x. So now when I rewrite it, 3 is my base, so I have 3. These two things switch places. I have 3 to the x equals 81. Well, now you just kind of have to reason through it. Well, let's see. I know 3 squared is 9. That can't work. 3 cubed is 27. That can't work. So 3 to the 4th, oh, I'm not sure. Look at my list. Oh, 3 to the 4th. Yep, it's 81. Now, if you just knew it was 3 to the 4th, you can jump right to that answer. So the faster you know these, then the less you're going to have to think through in your head and try and evaluate. So our final answer is that x equals 4. So if we were to evaluate log base 3 of 81, our answer is 4. All right, let's try this again on number 6. Oh, we got a lot of 5s and 6s. Oh, well, say levy. So this equals x. So when we write, it's 4 to the x equals 64. I think that part you should feel pretty comfortable with now. When I evaluate it, well, let's think through. Well, 4 squared is 16. 4 cubed, well, that would be 16 times 4. Oh, that is 64. So when we evaluate it, x is 3. Oh, this one should be easy. This equals x. So we have 7 to the x equals 49. Well, what to the x power is 49? Of course, it's 2. X squared is 2. 7 squared is 49. There you go. All right, one last one of this type. Now, second number 6. I guess this would be 7, 8, whatever. Okay, so this equals x. So we have 2 to the x equals 32. So if you're thinking, okay, well, I know 2 to the third is 8. I can look at my list. 2 to the fourth. 2 to the fourth is 16. That's not right. So I got to go a little bit higher. But I don't have to think that much harder because I know 16 times 2 multiplied by 1 more 2 would give me 32. So x to the fifth, or 2 to the, or x equals 5 is my answer. All right, so some of these you can figure out with out a calculator. And like I said, on standardized tests, this might come up. That's why I definitely want to show you. Obviously, through online school, I'm not going to be able to quiz or test you that way. I just want you to know how to do that if you were put in a position where you need to. You can evaluate using your calculator, and that's what we're going to do next. So the first thing that we're going to do is try and round to the nearest 10,000ths. Oh, so now we got to think about it. So the nearest tenth is one place after the decimal. Hundredths would be 2, thousandths 3, so 10,000ths would be 4 numbers after the decimal, and you know it's after the decimal because it's got a th on there. All right, so how are we going to put those in our calculator? Well, if we look at the first two, it's kind of interesting because there's no base on it. Okay, well, we talked about this earlier, but you know when we have a radical and it's square root of something and we don't actually write that 2, there's an invisible 2 there, if it ever erases. Okay, oh, whatever. Okay, so there's an invisible 2 there. Well, just that same idea, when you have logs, if there's no base there, they're assuming, or not assuming, they want you to know that this is a log base 10. So if there's no number, the base is 10. Now, we don't have to write it. If there's no number, it's just a known fact. It's kind of like when you take the square root. There's no 2, but you know it means the square root. So you don't put it in, you don't type it in your calculator or anything. Goodness gracious. Type in your calculator or anything, but that is what the base is when the base isn't given. It's always 10. All right, so how would you put this first one into your calculator? Okay, so to put this first one in your calculator, you are going to come over here to your calculator and look on the left-hand side in the middle, and there's this log button just to the left of the 7. So we're going to hit log, and then the first one was 78.4, and 4 decimal places, 8943. I look to the right, less than 5, so I chop it off. So 1.8943. All right, so we can go back and put that on our notes. This is 1.8943. Okay, what about the next one? Well, again, the log is just to the left of the 7, so I'm going to do log of 0.24. Oh, it came out negative. Interesting. Isn't that exciting? Just wild and crazy things going on here. Okay, so 7 is the 4th digit. Look to the right. That's more than 4, so I'm going to round up. So I get negative 0.6198. Okay, well, what if it's not a base 10? What is it then? Well, it's given to you. So on number 9, it's a log base 4. 10, it's 76. Okay, so how would we put that into our calculator? Okay, well, let's go to our calculator. And now, log with a base is not on one of the buttons. We're going to have to find it in one of the menus. And the menu where it's located is in the math menu. So you're going to go to the math menu. And then I think probably it'd be faster to scroll up, but you can do either one. But you're looking for option A, which is log base. And so now you're going to hit enter. And when you do that, that gives you an option to put that in. So the first one was log base 4. Scroll to the right to get inside the parentheses of 80. Whoops, I didn't type it very well. Take 2, 80. And then you get 3.4 digits would be 160. Oh, look, 9's the 4th place. It rounds up. So when I rewrite 1609, but rounding that 9 up, that 9 becomes a 10. So my answer would be 3.1610. And technically we should write the 0 because they want to know what's in the 10,000 spot. Well, you round and it's 0. All right, one more, put in our calculator. Okay, so to get to that menu again, I went to Math. You can scroll down, but it's faster to scroll up. I want option A, log base. Hit enter. So I'm going to have log base 3, go to the right of 76, and I get 3.9420. And there's no rounding because the fifth digit's a 0, so we're not going to round up, we're just going to chop it off. 3.9420. Okay, now that you're done taking your notes, you can do the homework and submit it like you did last time.